Now we are going to start katakoda Kubernetes seventh practical of the series. Uh, the seventh one is use Kubernetes to manage secrets and passwords. Learn how Kubernetes can help keep secrets secure. And I'm going to start the scenario. In this scenario, you'll learn how to manage secrets using Kubernetes. Kubernetes allows you to create secrets that are mounted to pod via environment variables or as volume. This allows secrets such as SSL certificate or password to only be managed via an infrastructure team in a secure way instead of having the password stored within the application's deployment artifacts. Uh, Going to start this scenario. It has a 4 steps. The first step is start Kubernetes. To start, we need to launch Kubernetes cluster. Execute the command below to start the cluster. CLI, Kubernetes CLI. Okay. This step 2 is create secrets. Kubernetes requires a secret to be encoded as base 64 strings. Coded strings. Uh, Using the command line tool, we can create base 64 string and store them as variable to use in a file. The secret is defined using YAML before using the variables defined above and providing them with friendly labels which our applications can use. This will create a collection of key value secrets that can be accessed via the name, in this case test secret. This YAML file can be used to with Kubernetes Kubernetes to create our secret. When launching pods that require access to the secret, we will refer to the via the friendly name. Create secret. Use Kubernetes to create our secret. The following command allows you to leave all secret collection defined. In the next step, we'll use this secret via pod. Step 3 is consume via environment variables. In the file secret env YAML, we have defined a pod which has environment variables populated from the previously created secret. We use the file using cat command cat secret dash env dot YAML. To populate the environment variables, we define the name. In this case, secret username along with the name of the secrets collection and key which contains the data. The structure looks like this. Value from uh, name secret username, value from secret ref name, test secret key username. Launch the pod using Kubernetes. Once the pod started, you output the populated environment variables. Uh, Kube, Kubernetes Docker decodes the base 64 value when populating the environment variables. You should see the original username and password combination we defined. These variables can now be used for accessing APIs, database, etc. You can check the status of pod using this command kubectl get pod. Mm. In the next step, we'll mount the secret as files. The fourth step is consume via volumes. The use of environment variables for storing secrets in memory can result in them accordingly leaking. The recommended approach is to use mount them as a volume. The pod specification can be viewed using to mount the secrets as a volume. First, define a volume with well-known name. In this case, secret volume, and provide it with our stored secret. Mm, When we define the container, we mount our created volume to a particular directory. Application will create the secret as a file from this path. Create a new pod using. Once started, you can interact with the mounted secrets. For example, you can list all the secrets available as if they are regular data. For example, uh, so read the files allows us to access the decode secret volume to access username. We choose for the password. We had read the password file. Uh, that's the end of our seventh scenario. We're going to start eighth one. That is liveness and readiness health checks. In here, we learn how to ensure containers health using liveness and readiness props. I'm going to start the scenario. In the scenario, you will learn how Kubernetes checks containers health using readiness and liveness props. Readiness props checks if an application is ready to start processing traffic. This prop solves the problem of the container having started, but the process still warming up and configuring itself, meaning it is not ready to receive traffic. Liveness prompts ensure that the application is healthy and capable of processing requests. I'm going to start the scenario. Have three steps in here. Step one is launch cluster. To start, we need to launch Kubernetes cluster. Execute command below start cluster components and download the Kubernetes CLI. Step 2 is readiness prompt. When deploying the cluster, two pods were also deployed to demonstrate health checking. You can view the deployment with this cat deploy by email. When deploying the replication controller, each pod has readiness and check. Each check has the following format for performing a health check over HTTP. Path. The settings can be changed to call different endpoints. For example, slash ping based on your application get status. The first one. Bad front end is HTTP service which always return a 500 error indicating it hasn't started correctly. You can view the status of the pod with this command. Crash off 58 seconds. Kubectl will return the pods deployed with our particular label because the health check is failing. It will say that 0 containers are ready. It will also indicate the number of restart attempts of the container. To find out more details of why it is failing, describe the pod. Mm, Readiness, okay. Our second pod from fronted returns okay status on launch. Step 3 liveness probe. With our second pod currently running in health state, we can simulate a failure occurring. At present, no crashes should have occurred. Crash service. The HTTP server has an additional endpoint that will cause it to return 500 errors. Using kubectl exec, it's possible to call the endpoint. Liveness based on the configuration, Kubernetes will execute the liveness probe. If the probe fails, Kubernetes will destroy and recreate the failed container, execute the above command service and watch Kubernetes recovery automatically. The check may take few moments to detect. Then there is a end of eighth scenario. It's end of seventh scenario. Going to start the eighth one. No, it's eight. Witness health check. Deploy the ninth one is deploy Docker Compose file with Compose. That's our ninth scenario. In here, we are going to learn how to use Compose to deploy existing Docker Compose definitions. And going to start the scenario. In this scenario, you will how to deploy existing Docker. Compose file to Kubernetes using Compose. Compose is a tool to help users familiar with Docker Compose move to Kubernetes. It takes Docker Compose file and translates it into Kubernetes resources. I'm going to start the scenario. It has 6 steps. Compose is deployed as a binary onto a client. To install Compose on katakoda, run the command. Details on how to install Compose OS can be found in this uh, link. I'm going to continue. Details on how to install Compose. Step 2 is up. Compose takes existing Docker Compose file and enables them to deploy it onto Kubernetes. Compose it is Compose is a tool for defining and running multi Docker applications, multi-container Docker applications, which Compose you use a Compose file to configure your application services. Mm, Copy an example Docker Compose file to editor. As with Docker Compose, Compose allows the images to be deployed using single command of the details of what has been deployed can be discovered with like okay. Step 3 is convert. Compose also have the ability to take existing Compose files and generate the related Kubernetes manifest files. The command uh, kubectl create. The files converted, they too can be deployed using kubectl. This will match the existing deployment applied. So OpenShift Compose also supports different Kubernetes distributions. For example, OpenShift, steps. Sixth step is convert to JSON. By default, Compose generates a YAML file. It's possible to generate a JSON-based file by specifying the J- parameter. That is the end of 8th scenario. Sorry, 9th scenario. That's the end of our 9th scenario. Uh, Now we are moving to our 10th practical of katakoda Kubernetes practical series. The 10th one is deploying from source onto a Kubernetes. In here, we are going to learn how to get from source to running service in Kubernetes. I'm going to start the scenario. Are you developer and want to play around Kubernetes? In this tutorial, we'll show you the basis of deploying service into Kubernetes from source code to running Kubernetes cluster. This is straightforward but more complicated than you might expect. Mhm. We have six steps. I'm going to start it. The container Kubernetes does not run your source code directly. Instead, you have a Kubernetes container. The container contains the compiled version of your source code and two. The second, any all runtime dependencies necessary to run your source code. In this tutorial, we are going to use Docker as our container format. We have created a simple web application in Python, the Hello web app, to package the web app as a Docker container. We create a Docker file. We have created a Docker file for you. So just type the following command to see its containers. This Docker file starts with the base image. Help to find install the necessary Python dependencies for the web app container. When the container starts, you can build Docker container manually with this command. This command reads a Docker file and then builds a binary image that contains everything necessary for the web app to run. Running your containerized service. In here, we successfully encapsulate the web app and everything needed to run container from the operating system helpline Linux to the runtime environment Python to the actual app hello world. Let's run the container. This command runs the container and maps the container port 8080 to the host port 80. We can verify that the web app is running successfully by this command. We are now sending HTTP request to port 80 on which then maps the 8080 in the container Kubernetes and the third step is Kubernetes and manifests. We have packaged up our service and now it's time to get it running in Kubernetes. Why do you need to? Why do you need? In short, Kubernetes takes care of all the details of running container, which VM server to run the container on making sure the container has the amount of memory, CPU, etc., and so forth. In order for Kubernetes know know how to run your container, you need Kubernetes. We have created Kubernetes hello with that service. You can see the if I contain some about your service tooling pointer to the top. We now need one more component before we can uh, the container registry. That is the fourth step. In order for your Kubernetes cluster to run an image, it needs to get a copy of the image. We typically do this through container registry, central service that hosts image. There are dozens of options for container registries for both on premises and cloud-only use cases. Uh, in this tutorial, the katakoda environment has provisioned a personal Docker registry to store the built image, set URLs for the registry as an environment variable with the command. In order to push the Docker image to registry, we need to create a tag for the Docker image that contains our Docker repository name. Docker tag hello with its command. Then we can push the image we just create to the Docker registry. Running the service in Kubernetes. Now let's actually get this service running in Kubernetes. We are going to need to update our deployment .yaml file to point to the image for our particular service. For the purpose of this exercise, we have templated our deployment file with the variable image, which will then instantiate with a sed command. If you run cat deployment of YAML, you will see that your specific Docker repository is now in the To gain access to the Kubernetes cluster, the Kubernetes configuration file needs to be downloaded from the master. The configuration file contains the IP addresses and certificates required to communicate security with the Kubernetes. And now we can run actually get the service running. Kubectl apply -f deployment of YAML. We are telling Kubernetes to actually process the information in the main first. We can see service running with services accessing the cluster. Now we want to send an HTTP request to the service. Most Kubernetes services are not exposed to the internet for obvious reasons. So we need to be able to access services that are running in the cluster directly. Uh, when the service was deployed, dynamic node port was assigned to the port. This can access via this command. Store the port assigned as a variable for later use. We can now send an HTTP request to the service. You will see the hello world message again. Congratulations, you got your service running in Kubernetes. The four pieces required for deployment we have just performed for main things. The first created a container, the secondly created the Kubernetes main first, the thirdly pushed the container to a registry, and fourth finally told the Kubernetes all about these pieces with an updated main first. So this was bunch of steps, and if you have to do this over and over again, suited for development, this would quickly grow tedious. Let's take a quick look at how we might script these steps so we could create a more usable workflow. Automating the development deployment process, that's the sixth step. Your service is now on Hacker News and you want to create a custom greeting, so let's change some of the source code. We could rebuild container, push it to the registry and edit the deployment, but you have probably all forgotten all exact commands, right? Luckily, Forget is an open source tool for deploying service onto Kubernetes, and it already does the automation and then some. Let's try using Forget to do this deployment. We need to do a quick setup for Forget. Uh, Set up to set up forget fog. Set up fog. Enter the URL for our Docker registry. Enter the username for registry in this case. To the registry again. With the fog configure type. Fog will automatically build your Docker container based on how you push the container to your registry of choice. Build deploy for you that points you mentioned. This process will take a few moments as a Kubernetes journey. Setting the newer code, we'll need to set up new port for as previously obtained the node port assigned to our deployment. Now let's check out our new welcome message. That is the end of our 10th scenario.